Chapter 1, Section 6 is about finding mean, median, mode, and range, and then translating that into box and whisker and stem and leaf plots. Bunch of vocab. Measures of central tendency are a description of data points. These measures of central tendency are mean, median, and mode. Your mean is the average. You take the sum of all your data points, so you add them all up, and you divide by the number of data points you have. A median is the number in the middle when you ordered the data set, and it has to be ordered from least to greatest. And then your mode is the number that appears the most. Mode and most kind of sound the same. Easy to remember that one. An outlier is a data value much higher or much lower than the rest of them. One that just doesn't fit with everybody else. Your range is the difference, remember that means subtraction, between the highest and the lowest data value. The bigger the range, the more spread out the data is. A stem and leaf plot is a display of data made by the digits of the data. We divide it into stems and leaves like this. And then a box and whisker plot is a display of data that breaks the numbers up into 4 quadrants. 2 of the quadrants are in a box, and then the other 2 are the whiskers that stick out. You have 2 objectives for this lesson. You need to be able to find the mean, median, mode, and range of a data set. And then you need to be able to make stem and leaf plots and box and whisker plots. We're just going to be talking about the stem and leaf and box and whisker plots in these notes, and then in class we'll actually be making them based on data that we gather. Alright, part 1, finding the mean, median, and mode. We need to find the mean, median, mode, and range of the data set, and then say which better describes the set of data. So if we're looking at this, the first thing I always do is I organize my data. It makes it really easy to find the median, really easy to find the range, and then the mode just appears because you have everything so close. So smallest number is going to be this 22. Let's write that one first. And then our next smallest number is 72. And then after that we have a 75, we have a 76, we have a 77, another 77, and then one more, and then a 78, and a 79. We have another 79. So now that my data is all in a row, it makes it really easy to find the mode. I have 2 numbers that appear more than once, 77 and 79. Since 77 appears more times, 77 is my mode. And then, like I said, this makes it really easy to find the range because it's your highest value minus your lowest value. And if we do 79 minus 22, we end up with 57. So there's our range. We have a pretty big range, which means our data is kind of spread out. There's a big gap in between our highest test score and our lowest test score. And then the median is the one right in the middle. And with this, I like to go through and start at the bottom, start at the top, and just keep crossing off until we get to what's right in the middle. And that's our median. And remember, if it ended up being like right in here, that's our middle, you have to take the average of those 2 numbers. And then our mean is the one that requires some calculation. We got to add all these up. So if I do 22 plus 72 plus 75 plus 76 plus 77 3 times, 78, and then 79 twice, I end up with 712. And then divide that by, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 test scores. I end up with 71.2. So now that we found all this, which better describes the data? Well, the range doesn't do a very good job of telling me anything about the data except how far away the highest and lowest values are. That doesn't tell me how people really did on the test. All that tells me is that some people did well, some people not so much. So that's not a good description. The median and the mode are the same, and the mean's a little less. Now, if you look at what the mean is, it's 71. Most of my data is above the mean. It's just this 22 seems to be bringing it down a lot, where the median and the mode are right here, right kind of in the middle of my data, especially because this is 3 points. So I would say that either the median or the mode better describe the data. And you'll find that happen when you have either a really high number or a really low number. We would like to call this an outlier. All right, so let's talk about our stem and leaf plots. There's two different kinds of stem and leaf plots. You can have a single stem and leaf plot or a double stem and leaf plot. A single one only compares one set of things. So in this case, this is test scores. And a good stem and leaf plot should always have a key so that you can read it. So 5-2 means somebody got a 52%. Somebody got a 53%. 65, 67, 68, on and on. Where a double stem and leaf plot compares things. Here we have city car gas mileage and highway car gas mileage. It's really easy for me to see in this comparison that most cars get somewhere in the 20s with their city gas mileage and in their 30s with highway gas mileage. And then again, it has a key. So this first part is normal. It's like the single stem and leaf plot key. But then this one's kind of weird. You kind of have to read it backwards because this is still our tens column and these are still our ones columns over here, even though they're written the other way around. So let's answer some questions. We're asked to use the stem and leaf plots to find the median of the test score data. So we can do the same thing that we did before, where we cross off the highest and the lowest and keep going in. And then remember, this reads 72, so that's my next highest number. Next lowest, next highest, next lowest, next highest, next lowest, and next highest. So it ends up being somewhere right in there, which means it's in between 68 and 69. So right in between those two numbers would be 68.5. Find the average. And then the mode of the city miles per gallon. So if we're looking city miles per gallon, we're just in this column right here. Which number appears the most? Well, we have this and this that both appear twice. So that means 23 and 31 both appear the most. We read the tens from here and the ones from over there, tens from here, ones from over there. Tomorrow we will be making these stem and leaf plots. So the third part, box and whisker plots. In a box and whisker plot, the data is split into fourths. The first and last quarters are our whiskers, and the middle two quarters make up the box. You need 5 pieces of information from the data before you can make a box and whisker plot. You need the lowest and the highest values. Those are like the ends of your two whiskers. Once you have those, you need the median, the number right in the middle, and that literally goes right in the middle of your stem and leaf plot, or your box and whisker plot. And then you need the first quartile and the third quartile. And those two things, take just the bottom half of your data and find the median of that. And then they find the top half of your data, the median of that. We also call these the upper quartiles and lower quartiles. But as you can see from here, we have 25% of our data grouped into each one of those spots. This bigger gap right here tells me that even though it has the same number of data points, there was less data here because it takes up more space. Where over here, where 25% of our data is clustered really close together, it's telling me that there was a bunch of numbers in between, in this case, like 100 and 140. So to get you thinking about what we're going to do tomorrow, I have a box and whisker plot here. You need to find the range of Seattle's points and the median of San Antonio's points. And then I'm asking you to read this box and whisker plot comparison. Create 2 inferences about the 3 box and whisker plots above. So that means take a look at this and pick out something that stands out to you. You can't use this one, but as an example, New York's range is way bigger than Seattle's range. Seattle might be a little higher, but the spread of New York is way bigger than Seattle. So that could be one inference. You need to come up with 2 more.